This screencast will cover how to choose the most appropriate statistical test for your analyses. The screencast will cover both non-parametric and parametric statistical tests. Although there are many statistical tests that can be used, we will cover only a select few. The few we will cover are the ones commonly used. You can find the assumptions of each of these individual tests in other screencasts. In these screencasts, you will also be instructed on how to run the test and interpret the results using SPSS software. You will also be given instructions on how to report the results. There are a variety of non-parametric tests. In this screencast, we will go over when it is most appropriate to use the most widely used non-parametric test. The chi-square test is applicable with nominal variables. For example, football team affiliation or gender. Nominal variables indicate the category a participant falls into using frequency scores. The chi-square test evaluates whether the observed frequencies in each category of a variable is different from what would be expected on the basis of chance or some known source of information. If you have one nominal variable with several categories, it is appropriate to run a one-way chi-square test. An example of a research question in which a one-way chi-square test would be appropriate to run the analyses is: a sample of SportX students was surveyed to determine whether they are type A or type B personalities. 23 were found to be type A and 9 were found to be type B. Is the difference in the frequency scores due to chance? If you have two nominal variables with several categories in each, then it is most appropriate to run a two-way chi-square test to analyze the data. We can take our earlier research example that was most appropriate for a one-way chi-square test and develop it into a research example that would be most appropriate for a two-way chi-square test. To do this, we need to add a second nominal variable. So the nominal variable we already have is whether or not students are type A or type B. The second nominal variable we can add is gender. Are students male or female? The two-way chi-square test essentially tests an interaction. That is, whether the frequencies in the categories of one variable are dependent or not on the frequencies in the categories of the second variable. In our current example of a two-way chi-square test, we are asking whether personality type A or B is independent of gender, male or female. It is important to note for both tests, each participant is allocated to one category of one variable. Repeated measures are not allowed. We will now go over a variety of parametric statistics. Most statistical tests at a basic level are parametric. If you wanted to look at relationships among variables, and you had one independent variable and one dependent variable, you would run a Pearson's correlation or a simple regression analyses. Pearson's correlation is the most widely used coefficient for examining linear relationships. A research question where it would be appropriate to use a Pearson's correlation is as follows. Is there a relationship between VO2 max score and age? Correlations can be used with multiple dependent variables and independent variables. However, you can obtain correlation between only two variables at a time. A correlation establishes the relationship between two variables based on their observed scores. Simple linear regression is a statistical procedure that uses a correlation to predict scores of y based on the known scores of x. An example of when a simple regression analysis would be appropriate is as follows. Assuming that we know the correlation between VO2 max and the Cooper's test, can we predict somebody's VO2 max from their time in the Cooper's test? If you are looking at predictions and have two or more independent variables and one dependent variable, it is most appropriate to use a multiple regression analysis. A multiple regression analysis would tell us how much of the cognitive anxiety variance is predicted by each of the contributors. There are a variety of tests we can use to look at differences involving variables that are only measured once. That means we only have one dependent variable. If you had one independent variable that had two groups, you would run an independent samples t-test. An independent samples t-test compares the observed differences between the means of two independent samples, for example, experimental versus control, or two different naturally occurring categories, for example, gender or age groups. An example of a research design where an independent samples t-test would be the most appropriate analysis is as follows. You train two random samples at either 70% of the VO2 max, sample 1, or 40% of the VO2 max, sample 2, for 2 months. You then ask them to run in a competition and record the distance they cover in 20 minutes. Is there a difference between the distance covered in 20 minutes between sample 1 and sample 2? If you are examining differences and have one independent variable and 3 or more groups, then it is most appropriate to run a one-way ANOVA. An example of when it would be most appropriate to run a one-way ANOVA is as follows. Each participant in a study is randomly allocated to one of the following groups: control group with no treatment, diet group, exercise group, and diet and exercise group. Group differences in body fat percentage are compared at the end of the intervention only. You have one dependent variable, body fat percentage, measured only once, and one independent variable, group, but there are 4 levels of that independent variable. If you had 2 or more independent variables with 2 or more groups for each of those independent variables, it would be most appropriate to run a factorial ANOVA to analyze your results. An example of when it would be most appropriate to use a factorial ANOVA to analyze your results is as follows. You are examining the differences between competitive and cooperative exercise climates and between males and females in exercise motivation. You have one dependent variable, which is only measured once, motivation to exercise, and 2 independent variables with 2 or more measures for each independent variable. The first independent variable is exercise climate, competitive versus cooperative, and the second is gender, males versus females. In the one-way ANOVA and factorial ANOVA examples above, if you had one or more covariates, then one-way ANCOVA or factorial ANCOVA can be used. We will now examine which tests are most appropriate if you have variables which are only measured once, but multiple dependent variables. If you have one independent variable with 2 or more groups and multiple dependent variables, you would run a one-way MANOVA. A research example of when it would be most appropriate to use a one-way MANOVA to analyze the results is as follows. Examine differences in intrinsic motivation, introjected regulation, and external regulation in a sample of 11, 12, and 13-year-old pupils. Your independent variable is age, and it has 2 or more levels. Your dependent variables are intrinsic motivation, introjected regulation, and external regulation. Therefore, it is most appropriate to use a one-way MANOVA. If you have 2 or more independent variables with 2 or more groups for each of those independent variables and multiple dependent variables, it is most appropriate to use a factorial MANOVA. We can turn our earlier research question into a research question that would need a factorial MANOVA analysis by adding a second independent variable. So we would examine differences in intrinsic motivation, introjected regulation, and external regulation in a sample of 11, 12, and 13-year-old males and females. Our independent variables would be age, and that has 3 levels, and gender, which has 2 levels. And our dependent variables would be intrinsic motivation, introjected regulation, and external regulation. Therefore, we would need to run a factorial MANOVA. If there were one or more covariates, one-way Mankova or factorial Mankova can be used. We will now go over the parametric tests for differences involving variables measured on multiple occasions, but only one dependent variable. If you have 0 between subject factors and 1 within subject factor that is measured 2 times, the most appropriate statistical test is a paired samples t-test. An example of a research question where a paired samples t-test would be most appropriate is as follows. Does squat performance improve from before to after a strength training program? In this example, there are 0 between subject factors, and there is 1 within subject factor, time, that is assessed on 2 occasions, before and after the strength training program, and there is 1 dependent variable, squat performance. Therefore, it is most appropriate to analyze the data using a paired samples t-test. If there are 0 between subject factors, 1 within subject factor that is measured on 3 or more occasions, then the most appropriate statistical test is a one-way repeated measures ANOVA. An example of when it would be most appropriate to use a repeated measures analysis is as follows. If you are assessing athletes' competitive anxiety 2 hours before competition, 1 hour before competition, and 30 minutes before competition, your within subject factor is your independent variable, and that is the factor that distinguishes measurements made on the same subject. So in this instance, your within subject factor is time. The within subject factor, time, is assessed on 3 or more occasions, and there is only 1 dependent variable, anxiety levels. There are no between subject factors. Therefore, it is most appropriate to run a one-way repeated measures ANOVA for the analysis. An example of when a factorial repeated measures ANOVA would be the most appropriate way to analyze the data is as follows. You are asking, are there any potential differences in the number of sit-ups performed over a 60-second period across 3 different types of music conditions dependent on the time of day the sit-ups occur. In this example, you have 2 within subject factors. Music, with 3 levels, no music, slow tempo music, and fast tempo music, and time of day, with 2 levels, early in the morning and in the evening. Participants will perform sit-ups early in the morning in each of the 3 different conditions, and in the evening in each of the 3 conditions. If you have 1 or more between subject factors, and 1 or more within subject factor that is measured on 2 or more occasions, it is most appropriate to use a mixed design ANOVA for your analyses. The design of a mixed design ANOVA is a combination of a between and within subject ANOVA. Unlike repeated measures ANOVA, a mixed design ANOVA has a between subject factor that divides the sample into distinct subgroups. Similar to a repeated measures ANOVA, a mixed design ANOVA has a within subject factor that distinguishes measurements made on the same subject. Similar to a repeated measures ANOVA, there is only 1 dependent variable. So, A mixed design ANOVA is used when you have at least two independent groups, which are measured on at least two separate occasions. An example research question, when it would be most appropriate to use a mixed design ANOVA, is as follows. Athletes with high anxiety levels are randomly allocated to one of three treatment groups: imagery group, relaxation group, and control group, and their anxiety levels are assessed on four separate occasions. The between subject factor is the anxiety treatment with three levels: the imagery group, relaxation group, and control group. The within subject factor is time with four levels: 1 week, 1 month, 3 months, and 6 months after the beginning of treatment. The between and within subject factors are the independent variables. The dependent variable is anxiety. This screencast covered when it is most appropriate to run different commonly used statistical tests. To follow up and see how to run these statistical tests, interpret the results, and write the results, and to know the assumptions of these statistical tests, please refer to the screencasts that correspond with each statistical test discussed.